Hi everybody. This is a review of Chapter 8, which is all about radical expressions. Question number 1 wants us to label the image. So take a minute now and label the image. Like terms is not really on here. Coefficient goes with letter A. Index goes with letter C. The radical symbol goes with letter B. And radicand goes with letter D. And all these other words were just there to distract you. Problem 2. Use Desmos. When you use Desmos, you should get an answer like this. Clear all this out. Okay, so we are finding the fourth root of 4096. So I go to the little keyboard, I go to functions, I go to number theory, I click on the nth root button, and I am doing the fourth root of 4096. And the answer should be 8. So my answer for this one is 8. Simplify the radical expression. So, sorry, let me delete that line. We want 2 factors of 80, okay? Because you can either look at this and find the perfect squares by looking at them, or you can break it down into primes. So I'm going to break it down into primes. So I can know I can do 8 and 10. 8 can be broken down into 2 and 4. 10 can be broken down into 2 and 5. 4 can be broken down into 2 and 2. So this becomes 1, 2, 3, 4 2s, 1, 2, 3, 4 2s, and 1 5. I have a pair of 2s, a 2 comes out of the radical. I have a pair of 2s, a 2 comes out of the radical, and then the 5 is left on the inside. 4 radical 5 is my answer. Simplify the radical. Okay, so what if you don't know what the perfect square is? Again, you can just write it in primes. So I know this is an even number, so I can divide by 2. 108 divided by 2 is going to be 54. Okay, so now I need 2 factors of 54. I know that 6 and 9 are factors of 54. Okay, I know that I can break down 6 into 2 times 3, and I can break down 9 into 3 times 3. So I can rewrite this as 2 times 2 and 3 times 3 times 3. Okay, and I'm going to take out the pairs. So 2 has a pair, so that comes out. 3 has a pair, so that comes out. And then I have 3 on the inside. The answer to this is 6 radical 3. Okay. The next one is radical 900. Okay. If you know the perfect square, that's fine. If you don't, we're going to break this down. So I can do 9 times 100. I can do 3 times 3. I can do 10 times 10. 2 and 5. 2 and 5. Okay, so I know I have 2 times 2 times 3 times 3 times 5 times 5. So I have 2 as a pair, 3 as a pair, and I have 5 as a pair, and I have nothing left inside there. This is 6 times 5, which is 30, because 900 is a perfect square, and the square root of 900 is 30. Okay. Simplify the radical expression. So remember that when we are when we are multiplying, we can put them all underneath the same radical. And now I can break these down. This is 3 and 5. This is 2 and 9, and 9 is 3 and 3. So I have 1, 2, I have 3 3s, and I have 1 5. Okay, so I have a pair of 3s right there. So that 3 comes out of the radical, and I'm left with 2 times 3 times 5 on the inside. So 3 radical 30 is my answer. Okay, again, we're multiplying, but this time I'm going to do things a little differently. I'm going to take the coefficients and write those first on the outside, and then I'm going to put what's under the radical on the inside. Okay, then I'm going to break down my 8 to 4 and 2. I'm going to break down the 4 to 2 and 2. I'm going to break down the 12 to 2 and 6, and I'm going to break down the 6 to 2 and 3. Okay, so now on the outside of my radical, I still have that 2 and that 5, so I'm just going to call that 10. On the inside, I have 1, 2, 3, 4, 5 2s. 1, 2, 3, 4, 5 2s, and 1 3. Okay, so I have a pair of 2s. So I've got 10, I've got 1 2. I've got another pair of 2s, and then I've got 2 times 3 on the inside. So on the outside, I have 10 times 2 times 2, which is 40. And on the inside, I have 6. Okay, now we're dividing. So remember, there are 2 ways to do this. You can simplify the radicals first, or you can divide first. In this case, it makes much more sense to say, hey, I want to take this fraction and put it underneath the radical first, because I know that 27 can easily be divided by 3. So then that becomes radical 9, and 9 is a perfect square, and that is 3. If you didn't know that 9 was a perfect square, you would have written 3 times 3 and seen that it was a pair and taken it out. Okay, we're still simplifying radicals, we're still dividing. So I'm going to treat this as if it's 2 different fractions, and I'm going to do them separately. So I'm going to look at this like it's 12 divided by 3 times radical 15 divided by radical 15 divided by 3, radical 3. Okay, so 12 divided by 3 is easy, that's 4. I'm going to rewrite this as 15 divided by 3 all under the same radical, because I can simply go 15 divided by 3 is 5. So now that changes to 4 radical 5, and that's the answer. I can't reduce it any more than that. Okay, the next one. We are simplifying radical expressions again, but remember, we are allowed to take the division problem and separate it. So we can rewrite this as radical 35 over radical 100. Okay, 100 is a perfect square, so that's actually just 10, and then this would be 5 and 7, which are both primes, so it actually is just going to be 35 on the top. But what if you didn't know that 100 was a perfect square? But you still can look at this and go, okay, I can't divide 35 by 100. I'm still going to break it up into those two radicals. So we'll leave radical 35 up top. We'll put radical 100 on the bottom. And I'm going to break this up into its primes, which is 5 times 7. Okay, and then 100, I'm going to break up into 2 times 50. Okay, so now I'm going to break the 50 down into 2 times 25, and I'll break the 25 down into 5 times 5. So on the top I have radical 5 times radical 7. On the bottom I have 2 times 2 times 5 times 5. So I'd take a 2 out, I'd take a 5 out, and I have nothing left in the radical. 5 and 7 are primes, so I make those 35. And then I took a 2 and a 5 out, so I have 10 on the bottom. Okay, so simplify the radical expression, and this one just has a variable. So we have to remember our rules for variables. We're going to look at the exponent, and is it odd or even? Okay, if it's odd, which it is, we make sure we put one variable underneath the radical. Then we pretend that this is a 26. We divide by 2. And that's the new exponent that we put on. That's the new exponent that we put on our radical. Okay, try the next one. Now it's even. Okay, well, if it's even, there is no more radical sign. Okay, so we take that out, and then we divide the exponent by 2. Let's use the Pythagorean theorem now. So remember, Pythagorean theorem is all about right triangles. So I'm just going to draw myself a right triangle. Okay. I know that C is going to be across from the right angle, and it doesn't matter what I label A and B. They're both just legs of the triangle. I know that the Pythagorean theorem says to do A squared plus B squared equals C squared. So 7 squared plus 24 squared equals C squared. Okay, so now I'm going to switch over to Desmos and do 7 squared plus 24 squared. And I get 625. Okay, so that means that 625 is equal to C squared. But I don't want C squared, I want C. So I have to take the square root of both sides. So now I'm going to go back to Desmos, and I'm going to take the square root of 625. And the answer is 25. So the missing part of my triangle is 25. And now the last thing that we did was we simplified radicals when we were adding or subtracting. Okay. So remember, I can only treat these as like terms if the number under the radical is the same. My first step is to make sure that I simplify the radical. Okay, so right now I'm looking, 32 and 72 are not the same number, so I have to simplify those first. Okay, so I am going to start with radical 32. And there was a 3 next to it. Okay, so we're going to start with that one. I know that I can do 4 and 8, and then this is 2 and 2, and this is 2 and 4, and 2 and 2. Okay, so I really have 3, and then 1, 2, 3, 4, 5 2s. One pair gives me a 2 on the outside, another pair gives me a 2 on the outside. So this is 6 times 2 is 12, radical 2. I'm going to go back and rewrite this as 12 radical 2. Okay, so now I'm going to do 5 radical 72. 5 radical 72. Okay, so the 5 is out there. I'm going to change this to 8 times 9. I can rewrite this as 2 times 4 and 3 times 3. Okay, and the 4 I can rewrite as 2 times 2. So this becomes 5 on the outside, and on the inside I have 3 2s and 2 3s. Okay, so a pair of 2s comes out, so I've got 5 times 2, and a pair of 3s comes out, so I've got times 3, and on the inside I still have a 2. So 5 times 2 is 10, 10 times 3 is 30, radical 2. Okay, so now I'm going to go back to my original problem. I changed this to 30 radical 2, and I'm still adding these together. Okay, so the coefficient can be added because the radical is the same number. The coefficients can be added because the radical is the same number. So I'm now going to add 12 plus 30, and that is going to give me 42, and the radical 2 just stays as radical 2, treating it just like we would treat an x. Okay. And that is your review of chapter 8.